Is it odd if you're willing to pay $40,000 for a particular license only to then ask the company that wrote the license code whether you could open source it? Or is it just me who's odd? Don't answer that. If you're new here, hi, my name is Tomasz, and together with my friend Aljaž, we developed a 10 gigabit router called Gateway. We started with development in March of 2024, and we're this close to shipping our first 1000 units of what we call the development kit. Unlike the regular mass-produced version of Gateway that we plan for later this year, well, if RAM ever becomes available again, that is, development kits serve a completely different purpose. First and foremost, they help us test what is called a product market fit, which answers a fairly simple question: is there room on the market for a product like ours? Or more importantly, is there enough room on the market for a product like ours? You see, we spent almost $1 million developing and manufacturing these first 1000 units, and of course we need to know whether we can make that money back, right? I mean, not immediately, and definitely not with just this first round of manufacturing, but eventually a business has to make money, otherwise it's nothing more than an overly expensive hobby, right? And apart from that, these development kits will also help us determine the feature set for the final version, because, well, in order to make money, we also have to, keep the costs low. And one way to achieve that is to take all the features away that people don't use and won't miss. I talked about this in my previous videos, but one example of cost cutting is picking a variant of the same CPU that has, let's say, 2 cores instead of what it currently has, which is 4 of them. Doing so would make the production cost around $25 cheaper, and because we don't rely on CPU cores for networking, the vast majority of customers wouldn't even notice the difference. Same goes with RAM, which at this point is almost amounts to half the price of the PCB. And don't mistake this laughter for joy, because I'm crying on the inside. But even in more, let's say, normal times, when we paid $14 per chip, and given we have 5 of them, if we split the capacity in half, you'd still have a 10 gigabit router with zero impact on the networking performance, while, again, shaving another $35 or so from the manufacturing price. I could go on and on about this, but I think you get my point. Development kits were not meant to be price optimized, they were meant to test whether market even wants what we're making and how much they're prepared to pay for it. That said, once we do sell throughout these 1000 pre-order units, we will of course make a retrospective and put all the invoices on the table, because, to be quite honest, I still have no idea exactly how much each unit costs us to manufacture, and the reasons for that are plentiful. You see, for some components and services we had to pay in advance, while for others we still haven't received the invoices. Some stuff we had to purchase ourselves, while some stuff our vendors have paid for. Then you have taxes, duties, air shipping. The point I'm trying to make here is that we focused on designing and shipping our devices as fast as possible, and once we're done with that, we're going to sit down and face the truth, you could say. I'll of course make a video about it as well, because as fun as, designing the hardware and writing firmware is, running a business also includes less fun stuff like logistics, legalities, and accounting, right? And since we're talking about the development kits, let me address one question that has been popping up on our Discord over and over, and that's whether they support Wi-Fi. In short, yes, they do, and yes, we have tested it, and yes, it works fine like it's supposed to, but there's a catch. The Wi-Fi cards themselves are not in the scope of delivery, meaning that if you'll want to have Wi-Fi on this device, then you'll have to purchase the M.2 card separately. You know what? Since we're talking about the scope of delivery, let's do a proper unboxing. As you can see, there are 3 ingredients here. So the router itself, flashed with OpenWRT and full hardware offloading support. More on that shortly. Then we have a 65 watt GAN power brick with a USB Type-C cable, and finally a power plug that you'll be able to choose at the checkout. I won't go over any details here because I think we've spoken more than enough about them throughout the past year and a half, but what I will do is answer one more question which folks that have pre-ordered these units keep asking, and that question is, when can I pay the rest of the money? Before I give you the answer, let me explain why I didn't want to take the money earlier. You see, we're a startup, and startups fail for a wide array of reasons, and I simply didn't feel comfortable taking all $600 up front until I was absolutely positively 100% sure that we will actually be able to ship the units to the customers who have pre-ordered them. Well, I'm happy to say that I am absolutely positively 100% sure now, because all 1,000 units are currently being manufactured and we expect their delivery by the end of this week, which means I'm finally comfortable publishing our payment page. Now, to prevent any kind of abuse, I'll of course keep this page hidden. Everyone that made their pre-order will get an email with the link to this page in the upcoming days, and then a couple of reminders in the following weeks, so don't worry, you won't miss anything. I'm saying that because some people reached out in December asking whether they can make their payments early just to make sure that they don't miss an email or a deadline. So I think it's worth repeating. If you're within the first 1,000 pre-orders, then we'll keep trying and trying to get a hold of you and only give your unit to someone else if we can't get a hold of you for more than a month. At any rate, if you haven't yet, go ahead and join our Discord because the whole team is coming together for this final stretch of production, and we'll of course be updating our Discord with progress pretty much daily. Okay, let's now talk about the hardware offloading. I've spoken about this firmware, also called ASK, in my previous videos, but unbeknownst to me at the time, NXP, who sells the license for this firmware, also allows for a delayed payment. Because of this and the fact that the shipping date was only weeks away, I felt confident enough and decided to pull the plug, made the order, and about 2 weeks later received the code necessary for the hardware offloading to work properly. Now, how should I put this? You know the feeling when you eagerly wait for something you've been anticipating for a really long time to happen, but when it does finally happen, you're kind of disappointed? Well, that's how I felt, and the reason I felt disappointed was the state that this code was in. Or should I say that the state that this code was not in, as in it was not up to date. In fact, all the files that I've been given access to were last modified in August of 2022 for kernel version 5.4. Now, I wouldn't blame you for not being up to speed on kernel releases and versions, but 5.4 is old. In fact, it reached its end of life in December 2025, 6 years after its release. Now, don't get me wrong, old doesn't necessarily mean bad. I mean, just look at me, right? I mean, most embedded devices run for ages with zero problems, right? In fact, it's often even preferred to have a mature platform running on these, simply because it's been battle tested, patched, and proven to work reliably. But 6, almost 7 years for the code that we paid $40,000 to get? Yes, 14 grand is how much we paid for this, so you'd at least think, or expect to have, at least a couple of versions for different kernels that we should be able to decide which version to go with, right? To be honest, this whole hardware offloading thing to me looks more like an afterthought than anything else. I mean, the code, that is. I mean, don't get me wrong, it works fine and we'll get there shortly, but still, for 40K, I was expecting more, I'm not gonna lie. This video is sponsored by PCBWay. When I developed my custom mechanical keyboard, PCBWay manufactured both the prototypes as well as the production PCBs, and the quality was nothing short of exceptional. So, for our router project, I knew exactly who to turn to. They've produced prototypes for us throughout this entire journey, like the M.2 fit test cards, CNC milled plastic and aluminum enclosures, and even some parts for the final production units. PCBWay offers everything from PCB manufacturing to 3D printing, injection molding, and even sheet metal fabrication. Check them out using the link in the description. Before we get to how it works, let's talk about the porting process itself, as in how we succeeded to rewrite the majority of the code that was initially written for 5.4 kernel and made it work with the version 6.12. Notice how I said we? That's because I had help, and I never thought I'd say this out loud, but it was AI, Claude Code to be specific. Now, before you pull out your pitchforks, let me clarify one thing. This is not an AI good versus AI bad video. I'm not trying to convince you one way or the other, and in fact, I know far too little to be of any kind of authority on the matter. What we're about to discuss is simply me exploring and using the tools at my disposal, and whether you want it or not, large language models are here to stay, and I'd rather be ahead of the curve rather than be left behind, right? So, with that out of the way, here's how it all went down. The latest stable version of the kernel that NXP released at the time of us writing firmware for the development kits is 6.12.49. So I simply went ahead and cloned their kernel into a directory, put the ASK patch in patches directory that Linux already has in gitignore, and simply told Claude the following. In patches directory, you'll find a patch that enables hardware offloading on the NXP LS1046A CPU that we use on our custom-made single-board computer. This patch was written for kernel 5.4, but we use 6.12 in production, so the first thing I want you to do is apply the patch to the kernel source. This will, of course, result in a number of rejections, but before you fix them, I want you to create a new file in the patches directory called progress.md. At first, I want you to put all the rejections into a table in this file, and as you go along, tick each solved rejection off so we can keep track of your work. Once you have the table ready, go ahead and solve all the rejections one by one. Before you begin though, I want you to take the LF61249 commit of the kernel and branch it off to a new branch called monoask, so that once you're done, you'll create a proper diff for the final fully ported patch. See what I did there? I purposefully gave it everything it needs to know to complete the task successfully. I gave it the context, the steps I wanted it to take, how to begin the whole process, and finally what the success criteria looks like. You're probably familiar with the term vibe coding, and everyone most likely has their own idea what it is, but for me, vibe coding is asking AI to write code because you lack the skill to do it yourself. Well, in my case, this was anything but. You see, there are two distinct modes when it comes to Claude's interface, at least in Visual Code Studio, which is what I use for development. You have the edit mode and you have the planning mode. I always, and I mean always, start with planning mode. In this mode, Claude won't do anything, it'll just take your prompt and then explore the environment it's in to understand the bigger picture and finally come up with a step-by-step plan, which is the combined result of your prompt, the code base that you're running Claude in, which in our case is the Linux kernel, and finally its own understanding of the two combined. In case it has any further clarifying questions, it will of course ask them, but ultimately it will present the plan and ask to exit the planning mode, which will put it into editing mode, and in this mode the no command restriction is off. Meaning it can edit files, run Git, and even compile the kernel if you wanted to. In fact, let me show you another prompt I entered once all the rejections were resolved. Monoask branch has been committed to the kernel source, and a patch has been generated in patches directory by diffing the monoask branch against the LF61249 tag. I want you to build this kernel, and in case there are any issues, make modifications to the mono-ask branch, then try again. Do this until the kernel builds successfully, then append your changes to the last commit and regenerate a new patch. There's a catch though. We use Yocto to build this kernel, so we prepared an SDK for you, which means you have to prepend any and all make commands with source to the SDK so that the correct cross-compilation tools are used in building this kernel. See, again, all the context it needs as well as a clear instruction for what to do. Now, I am oversimplifying a little because this did take a couple of days actually, simply because the original patch creates 24 new files, but what's even more important, it patches a whopping 138 existing files. And there's even nuance to this because the kernel evolved quite significantly between versions 5.4 and 6.12, meaning that not all files that it wants to patch are necessarily even there anymore. So we had to find where the functionality that the patch was supposed to change has been moved to, right? And again, I say we here because Claude Code also comes with another very useful feature. It's thinking out loud. If you click this little gray arrow, its thought process gets revealed and you have two options. You either ignore it or you pay attention. And for production code that we're about to ship on our devices, you can bet your ass I paid attention. I'm sure you've heard the term hallucinations when it comes to AI, and Claude is no exception. They're not very frequent, but they do happen, and Claude will make a wrong assumption about something, which will result in a wrong decision being made, but it's not a big deal. This is where the stop button comes in. You click whenever you feel it made the wrong decision, regardless if it's hallucinating or not. For example, it wanted to modify the source code differently than I would have if I did it myself, so I stopped it, turned planning mode on, and asked it to explore a little bit more into details and even present me with the pros and cons of his approach versus what I would have done, right? This approach eventually brought us to the kernel being built successfully, but once I flashed it, I would see a panic or some other error. Again, Claude proved invaluable here. I'd simply turn on the planning mode, pasted the error in, and within minutes I'd have a new version to flash and boot into. This step alone would take me weeks if I had to do it all by myself, but with Claude Code, it took an afternoon. But the kernel is only half of the story. You see, there are also a handful of libraries and modules and user space programs that all needed to be ported to 6.12, and I took the exact same route. So I'd show the source code for each of these to Claude, tell it to analyze it, and finally to build it using the Yocto tooling, which, as we already established, includes the 6.12 version of the kernel. All these packages, along with the 18,000 line kernel patch that we developed in the previous step, have been released under GPL, which means we're free to publish them on our GitHub, so I'll leave the two links in the description down below. One to the ASK patch and other to the repo with all the dependencies that we just spoke about. There is, however, a third ingredient that allows for the hardware offloading to work correctly, and that's the firmware. It's a binary that we're supposed to flash on the NOR chip and luckily isn't operating system dependent, meaning it doesn't care which kernel it's running on the board. In a way, that is good, right? Because there was literally no additional work for me to do apart from flashing it to the NOR chip. But it does come with a price. And I'm not talking about the 40K that we pay for the license, but the fact that we're not allowed to publish it anywhere. I mean, I get it, right? This is NXP's proprietary code and they can do with it as they please. And we will, of course, play by their rules. But I've literally asked them what kind of restriction is that, given that literally anyone with a board can extract that very same binary from NOR flash by running a simple command in Linux, right? As of recording of this video, I'm still waiting for a reply on that, and I'll let you know their answer in one of my future videos. So for now, let's focus on more pleasant aspects of the ASK, the fact that it works. And boy, does it work. I prepared the patched version of OpenWRT that all of you will get as the primary operating system, and that was a whole other can of worms, given it uses the mainline kernel, which requires yet another massive patch to bring in all the NXP stuff, plus the ASK patch from our Yocto. But the point is, we promised a 10 gigabit router, you paid for a 10 gigabit router, and you'll receive a 10 gigabit router. I won't go through all the protocols that can get hardware offloaded with these patches, simply because NXP's sales page already does a good enough job of explaining it. So before you ask down in the comments, is my favorite protocol supported? Well, if you can find it on the website, then yes, it is. The only unknown here is the OpenWRT build that our routers will ship with. I mean, we've tested it quite thoroughly, but you know, testing in a control environment by 2 people isn't the same as testing 1000 units out in the wild. But to be honest, I'm not particularly worried. Even if there is an issue, we'll simply fix it and send all of you the updated version, right? And speaking of OpenWRT, here's where I need your help. You see, in order to be able to ship the device with hardware offloading already baked in, some corners had to be cut, otherwise I simply couldn't have made it in time. And don't worry, it's still your stock OpenWRT, it's just patched with the ASK code and, you know, a couple of files for the definition of our hardware. But to get to this point as quickly as I could, I paid very little attention to the organization and best practices when it comes to adding new hardware to OpenWRT. I literally branched off version 25.12.0, which is the second release candidate, but the main reason is that it has the same 6.2 kernel that we already patched, which meant I could save some time by reusing our Yocto patch, right? I'll leave the link to my work down in the description, and I invite anyone who's interested, or better yet, has experience with OpenWRT development to have a look. And if you find anything that you think can be improved, please knock yourselves out in the GitHub issues page. If you've been following along up to this point, thank you. You're an absolute legend. Go ahead and click that like button if you haven't yet. This is likely the only video for this month because, as I said earlier, we expect the final PCBs to be delivered to our warehouse in the following days. And the whole team is all hands on deck because we want to finish too, but flash all 1000 of them with firmware and operating system. Then we have to assemble them, package them, you know, turn them into a final product that will serve you well for years to come. So, because applying these feet onto the aluminum base is somewhat cumbersome, we came up with this 3D printed contraption. It basically allows us to plug it into the vacuum cleaner and then it kind of pulls the foot in place. So then we can just press the aluminum enclosure against it and it will stick first try. It will stick almost perfectly. So if some of them are slightly misaligned because of the tolerances, I'm sorry, it's my fault. Now let me show you how it works. There we go. Almost perfectly aligned. Now we just have to give it some time for it to cure properly, but it will do that inside the crate where they're being stored, right? Cool, right? We'll of course record everything and likely make more than one video once this all blows over, but if you'd like to follow along more closely, then you're of course welcome to join our Discord where we'll post updates pretty much daily. Tomasz from Slovenia, signing out.